Principle of the water supply pump system. When the start button is pressed, the run lamp turns on, indicating the system is ready to operate. When sensor 2 is activated, the pump is running, and when sensor S1 is activated, the pump stops. Sensors S1 and S2 can be simulated on the HMI using simulation buttons. Pressing stop will stop the system, and the run lamp will turn off. To study this lesson, I will use a sample project from the previous lesson. Open device and network to connect the HMI and PLC. I will drag and drop the HMI to the PLC. Then select Connection tab and drag and drop the HMI to the PLC. Open the HMI screen and start designing. Create the necessary buttons and indicator lamps. Now, open the simple factory software. Drag and drop the tank onto the HMI screen. To design the pump, I need to create a graphic list. This system has 2 sensors, so I will create an additional graphic list for the sensors. The sensors have 2 states, 0 and 1. I will rotate at 90 degrees and drag and drop the sensor onto the HMI screen. Back to the screen, drag and drop the graphic onto the screen. Do the same for the sensors. Now, I will create a pipeline connecting the pump to the tank. Because the system has a sensor simulation function, I will add a sensor simulation function here so that the tank can display its state when full and when empty. I will add a rectangle. When empty, I will display it in black. Then copy the black rectangle and change it to green when the tank is full. Now place the green rectangle over the black one. After designing the HMI interface, we are ready to start programming the PLC. Open PLC tag and add a new tag table. The physical input memory for sensor S1 will be prefixed with an I. And the address for S1 is I0.0. The physical memory for sensor S2 is I0.1. Since sensors S1 and S2 can be simulated on the HMI, I will add two tags for these sensors on the HMI. Because these are HMI addresses, I will change them to a memory. Address for S1 is M10.0. Similarly, I have sensor S2 on the HMI with memory M10.1. Start button on the HMI. Stop button on the HMI. Simulation button on the HMI. Run lamp with memory is Q0.0. Pump control output with memory Q0.1. Since sensors S1 and S2 have two sources for tag values, one from the physical memory I and one from the HMI simulation, I will use a common tag to combine these two signals into one. Name the common tag S1 with a bool format. And its memory is M11.0. The same goes for S2 with memory M11.1. Open the main program and start programming. First, combine the sensor signals. The physical input signal S1 and the HMI signal S1 will output the signal S1 for display, with the condition that I use the HMI signal S1 when simulating. Therefore, I will place a normally open contact of the simulation tag before it. When not simulating, I will use the physical memory IO.0. So this will be a normally closed contact of the simulation tag. Sensor S2 is handled similarly to sensor S1. Program the system control. When the start button is pressed, the run lamp turns on. When the stop button is pressed, the run lamp turns off. Maintain power with the normally open contact of the run lamp. Now program the pump control. The pump will only be on when the run lamp is on. When S1 is active, indicating the tank is full, so I will reset the pump when S1 is active. When S2 is active, indicating the tank is empty, I will set the pump to on. If the run lamp is off, the system is stopped. Need to turn off the pump. Now start assigning tags to objects on the HMI screen. The press attribute of the start button will set the bit, and the tag used is HMI start. The release attribute will reset the bit, and the tag is also HMI start.
The stop button is handled similarly to the start button.
The simulation button will use the invert bit function. Press once to turn the bit on, and press again to turn it off. I will also change the color of the simulation button. When the tag is 0, I keep the default color. When the tag is 1, change the button color to green. And the tag used is HMI simulation. Set the colors according to the tag value for the run lamp. When the tag is 0, keep the default color. When it is 1, set the color to green for the lamp. For the pump, I will assign the pump tag. Sensors S1 and S2 are handled similarly to the pump. Note that you need to set the symbols in output mode. There are two overlapping rectangles, green and black. The black rectangle remains as the background for the water level. The green only appears when S1 is active. Therefore, in the animation attribute, I will assign the S1 tag to the display visible function. The green rectangle will only display when the S1 tag is on, so I set it to from 1 to 1, meaning it only displays when the tag value is 1. After assigning the tags, overlay the green rectangle over the black one. Now assign tags to the simulation buttons for sensors S1 and S2. The S1 on button sets the bit. The S1 off button resets the bit. The sensor S2 buttons are handled similarly to S1. Run the simulation and check the results. Press the simulation button. Then press the start button. When sensor S2 is active, the pump will run. And when sensor S1 is active, the pump will stop. The tank full icon is displayed in green. To make the system more realistic, I will hide these objects when I am not simulating. Back to HMI, select all and in the animation visible attribute, display the S1 and S2 buttons only when the simulation tag is on. Now, when the simulation tag is 0, these objects will be hidden. When the simulation tag is 1, these objects will be displayed. Run the simulation and check the results. Now, because the simulation button is on, these objects are displayed. When I turn off the simulation button, the simulation objects will be hidden.